Welcome everybody to this class, and today's topic will be about inequalities. We did a class on inequalities last time, and we will be doing more inequalities, which will be more complex and harder inequalities. So please pay attention during this class and expect everyone to try during the practice problems. And let's start then. Well, if you can recall last lesson on the title slide, it was the background was a bunch of swirlies. And that was what your mind was probably after that lesson. Well, look at this background. This is what your mind is going to be after this lesson. So good luck, kids. All right, schedule. Review on inequalities. At least half the class should know that. Shouldn't get too hopeful. And solving inequalities with a sign chart. That's the new material today. And we're going to go through practice problems, of course, after we learn the material. So are there any questions? Oh, right. I'm not even sharing my screen. Thank you for reminding me. I do that a lot, so bear with me. Hold on. Okay, I shared my screen. So this is what your mind is going to be after the lesson, yes. So, and the schedule, well, you already know that. You can read. Of course you can read. It'd be very disturbing if you couldn't read. Oh well. So, let's start with a brief review of absolute inequalities. And these are just some important theorems that you should know when solving inequalities. So, can everybody see my screen now? Oh. Yes or no? Just say something, kids. Not that hard. Can you see my screen? Yes or no? Yes, very good. Okay, so let's start. For any a that is greater than 0, the absolute value of x is less than a. What does that mean? That implies that negative a is less than x and x is less than a. Okay, so x is greater than negative a and x is less than a, so it's and. And the graph of this, would be just one interval. It'd be one enclosed interval. So I'll give examples on that later. And when the absolute value of x is greater than a, then that means x is greater than a, or x is less than negative a. Because if you combine those into a compound inequality, they don't make sense. So that's why we use or. So the interval here would actually be two intervals. It'd be like this. So some examples would be this is negative 2 to 2. Right? A is 2. And negative a would be negative 2. So this interval, the absolute value of x is less than 2, be x is less than 2 and greater than negative 2. So in interval notation, that would be negative 2 to 2. And the absolute value of x is greater than 2, then you'd have x is greater than 2, or x is less than negative 2. So it'd be two intervals. And how do we write that? We use the union sign. So negative infinity to negative 2, union 2 to infinity. So that's how we write that. So in other words, if you erase this a 2 here, it'd be negative a to a and negative infinity to negative a union a to infinity. So that is one important theorem we should know. And also, that's only for a is greater than 0. Now, what about a is less than 0, meaning it's negative. So if a, the absolute value of x, is less than a, then that's actually no solution because absolute value must be positive. So if a is less than 0, meaning it's negative, then absolute value of x is less than a implies that there is no solution. Now, for absolute value of x is greater than a, then it should be all real numbers because absolute value of x is greater than negative 5. That's true. That's true in every possible scenario because absolute value of x is always greater than or equal to 0. So if the absolute value of x is greater than 5, then all real numbers fit as x. So there are really no restrictions there. So then that would imply it's all real numbers. So are there any questions? Are there any questions? If you have any questions, please put them in the chat and I'll go over them again. If there are no questions, I'll move on. So let's do some warm-up problems. All right, these are from last lecture. So please review your notes from last lecture if you have been to last lecture. If you have not been to my last lecture, but you still know how to do these, then please do. And put your answer in the chat once you're done. I'll give you a few moments. If you do not know how to do it, then please wait until I explain how to do it. All right. I at least expect everybody to try to do these. They are very similar to linear equations, so keep that in mind as you're solving. They should not be too hard. Also, remember that a key point, right? A key point is that, where should I write this? Key point, all right? Key point is that when multiplying and dividing both sides by a negative number, flip the sign. You must flip the sign. All right, now you don't need to do that actually you do need to do that in this problem. Yes. So please keep this in mind when you're solving. So the key point is when multiplying or dividing both sides by a negative number, please flip the sign. Okay? Because you might make errors if you don't. So are there any answers yet? No solution. How come no solution? All right, Edward says it's negative 11 over 2 to 13 over 2. All right, are there any other answers besides Edward's answer? Any other answers? If you have any answers, please put them in the chat. I'll give you a few more moments to solve this. Okay. All right, so there are no answers. Besides Edward, of course. Very good, Edward. You got the correct answer. Stephen, would you like to explain how you got no solution? The very simple inequality. I would like to know how you got no solution. Ah, I see. You're so stupid. Miscalculation. Well, you're good for a fifth grader. It's good. Anyways, so what do you do next after what do you do first actually? Well, you see this fraction, we don't like fractions in algebra. We don't like fractions in algebra. So we're going to get rid of that. What is the opposite of division? Should be very easy by now. It's multiplication. So multiply all sides by 3. Negative 9 is less than 4 minus 2x is less than or equal to 15. All right. And then after you do this, what do you get? You get negative 5 is less than negative 2x is less than or equal to, wait, no, sorry about that. It's negative 13. Okay, so you subtract 4 from all sides, and then this would be 11. All right. After you do that, you need to divide all sides by negative 2. So divide all sides by negative 2, and remember this key point. Remember this key point. Whenever you're multiplying and dividing, or dividing, actually, or dividing both sides by a negative number, please flip the sign. So we are dividing by a negative number right here. So our answer should be x is greater than or equal to negative 11 over 2 and is less than 13 over 2 because we flipped the signs. Okay, and in interval notation, it would be this. Negative 11 over 2 to 13 over 2. All right. And why this bracket and why this parentheses? So if you studied interval notation before, domain and range, then you should know that if there's a square bracket, that means, why am I on eraser? If there's a square bracket, right, there's a square bracket, then that means you should include it, all right? You're including negative 11 over 2. But x is strictly less than 13 over 2, so you don't include that. If you don't include that, then that is a parentheses. All right. Are there any questions on how we are able to do this question? Are there any questions? Any questions? If you do have any questions, let me permit everybody to unmute. All right. I'll allow you to unmute yourselves because this is quite a hard lesson and you might not understand at all. So please feel free to blurt out or interrupt me if you have any questions. All right. So let's continue. Our second warm-up question is an absolute value inequality, and we just reviewed two theorems about absolute inequalities. So please, if you wrote those down, please review them or recall them, and please do this problem. I'll give you a few moments, 1 or 2 minutes, and put your answer in the chat box. Right. Are there any answers yet? All right. We have negative 1/6 is less than or equal to x, which is less than or equal to 5 over 6. All right. You have one answer. Are there any other answers? Any other answers? I'll give you a few more moments to solve this. All right. I'll give you a few more moments to solve it. Okay. All right. So let's do this problem. Okay, Stephen and Edward, you seem to have different answers, actually. Because Stephen, yours is an or answer, which means there are two intervals, while Edward's answer is actually only one interval. Right, so we have some different answers, so let's see which one is correct. So what we need to do right here is we need to move this 5 to the other side, and then we divide by this 2. Okay, and then we solve. So let's do this just that. So we move the negative 5, the 5 to the other side. All right, and that's what we get. And then we have what? 3x minus 1. We divide both sides by negative 2. Remember to flip the sign when you're dividing by a negative number. All right. And then after that, you see this is because the absolute value of 3x minus 1 is less than or equal to 3 over 2, then it's an and inequality. So, Stephen, that's where you went wrong. It's an and inequality, not an or inequality. So, let's solve. 3x minus 1 should be less than or equal to 3/2 and greater than or equal to negative 3/2. So we add 1 to both sides, and we get negative 1/2 is less than or equal to 3x is less than or equal to 5/2. Okay, and then we divide all sides by 3. And we should get negative 1/6 is less than or equal to x is less than or equal to 5/6. So the interval we get here is negative 1/6 to 5/6. And we use square brackets because it is included. Is included. Right? We include negative 1/6 and we include 5/6. So Stephen, do you understand your mistake? Are there any questions? Okay, very good, very good. So let's start our third problem. Okay, and be careful on this one. So I'll give you a few moments to do this problem as well. I'll check back in a one or a couple minutes. All right, give you a couple minutes to solve. All right. And this is actually a pretty tricky problem. So you can only solve it if you know a specific theorem, but I'll let you guys try to solve it or brainstorm ideas first. So let's do that. All right, we have one answer. Very good, Stephen. X is greater than 2. Very good. All right. So how did you get x is greater than 2? How do we go to this to x is greater than 2? Well, let's first notice that x minus 2, we don't know what that is, right? We don't know if it's positive or if it's negative. Usually, if this were a linear equation, change the inequality sign to an equal sign, of course, we would cross multiply, right? It's very natural. We would cross multiply. Okay. However, if you cross multiply right here, you don't know if it's negative, positive, or even 0. If it's 0, that's worse. It's undefined. So you really can't cross multiply because you don't know the result. And furthermore, if you cross multiply, you would get 3 is greater than 0, which is all real numbers. Okay. So how do we solve this? So let me introduce a theorem. Okay, please write this down in your notebooks. Theorem. Okay, so if a is greater than 0, for any a is greater than 0, that implies that the reciprocal of a is also greater than 0. All right? That implies that the reciprocal of a is also greater than 0. Okay? And also, if a is less than 0, that implies that the reciprocal of a is less than 0 as well. So how do we, let me give an example. For example, negative 5, that's negative, right? 1 over negative 5, that's also negative, right? So these are two theorems that you should know. So using this theorem, since 3 over x minus 2 is greater than 0, then the reciprocal of that x minus 2 over 3 is also greater than 0. All right. So once you cross multiply, move the 2 to the other side, x is greater than, x is greater than 2. All right. So there you have it. That implies that the interval notation would be 2 to infinity. All right. So this is important. Never cross multiply unless you know its value. All right, never cross multiply unless you know its exact value, right? Except for if it's a real number or you know its exact value. So you can cross multiply 3, right? That's positive. It won't change the sign, it won't flip anything. However, you can't cross multiply x minus 2 because you don't know its value. It might be negative. Then you have to flip the sign. If it's positive, you don't flip the sign. So you really don't know. X minus 2 may even be 0. So that is why we use these two theorems to solve. Right. We spent, okay, yes. Multiply 3 to both sides. Very good. Okay, so great. Now let's move on to some more, to new material, okay? And this is kind of hard. This is pretty hard, so please take notes on this, and if you have any questions, feel free to interrupt me. And I'll also check the chat frequently. So let's start with an example. All right, let's start with an example. So let's start with 3x squared. Also, please note that factoring is key here. Factoring is key. Right? Always factor, always factor. Okay. Factoring is very important when you're solving these kind of inequalities. So our example is 3x squared minus 21x plus 30 is greater than 0. All right, so how do we solve this? How exactly are we going to solve this? Okay. Does anybody know how we are going to solve this? So what are our first steps? Factoring, right? Let's factor a 3 out. Let's factor a 3 out. So here is the solution. Right. Is a solution. So let's use green. So x squared minus 7x plus 10 is greater than 0, and you factored the 3 out. But the 3 really doesn't matter, right? It really doesn't matter, because if this x squared minus 7x plus 10 multiplied by 3 is greater than 0, the 3 doesn't matter because it's positive. No matter what you do with the 3, if you multiply it to something, it won't change anything because it's positive, always. So you don't need that 3. Also, you can just divide it off. So after you do that, you factor x minus 5 times x minus 2. Right? That is greater than 0. So now what do you do? So let's review. Okay. If AB, all right, this is the zero product property. If AB is greater than 0, then that means that either A is greater than 0 and B is greater than 0, meaning A and B are positive. And two positive numbers, when you multiply them together, they make a positive number. Our other situation is that A is less than 0 and B is less than 0. So when you multiply two negative numbers together, you get a positive number as well. So that is what we're looking for. All right, so we clear up some space here. We're going to need quite a lot of space to do this. All right, so how are we going to do this? Well, the thing is, we're going to create a sign chart. All right, are there any questions so far? Any questions so far yet? Okay. All right. Reza, that's not entirely correct. Though you did get one thing correct. You got x is greater than 5. Yes, that is one interval that is correct. So, how are we going to do this? First, we're going to make a sign chart, right? Hold on. I need to create a better line there. I'm going to make a sign chart. All right. Going to be too big. All right, so create a chart to help you. And what are we going to put on this chart? So on the top, what are the values that make 0? Right. We're going to list all the intervals that make 0. So negative infinity to 2. Okay. Actually, never mind. I should not do that first. So let's list all the factors that make this 0. Okay. So 2 is 1. All right. 2 is 1. 2. And 5. Okay, those are two spots that you should not go to. Right, and since this you're trying to make it greater than 0, right? So you should not include this as well. If it's greater than or equal to 0, then include these as well. So what do you have? You have a bunch of intervals now. You have an interval here, you have an interval here, and an interval here. You have 3 intervals. So that's how many you're going to put on the top of your chart. All right, so one interval is negative infinity to 2. All right, negative infinity to 2. All right, and our second interval, 2 to 5. All right, and then 5 to infinity. Those are our intervals that are actually possible. All right, now let's list our factors. X minus 2 and x minus 5. All right, I don't need this big of a chart. Hold on. This will suffice for now. All right, so these are our factors, okay, and these are our intervals. So what we're basically doing here is we're creating a sign chart, right? These intervals, when is okay? Let's do it, and then perhaps you'll understand further. So when is x minus 2 positive? X minus 2 is only positive whenever x is greater than 2. So you actually have to solve this inequality. Okay, it's only positive when it's greater than 2. Right, so these two intervals, if you multiply them, if these two intervals are positive, this interval is not, because, for example, negative infinity to 2, that includes negative 3, right? Negative 3 minus 2, that's negative. Now 2 to 5, all right, that includes 4. 4 minus 2 is 2, that's positive. Great. So let's look at our other factor, x minus 5. So what can x be to make it positive? What can x be, right? It has to be greater than 5. So it's x minus 5 is only positive when x is greater than 5, all right? So these are negative. Now, look at this. These intervals, we've looked at when x minus 2 is greater than 0 and when x minus 5 is greater than 0. So we're going to multiply them together now. Remember, 2 negatives make a positive and 2 positives make a positive. So when you multiply these two together, you get positive. When you multiply these two together, you get negative. We don't want that. When you multiply these two together, 2 negatives make a positive. We want that. Great. So we've got our answer now. It's negative infinity to 2 union 5 to infinity. So you see here, don't try all those theorems or methods. Right? This is the fastest way, all right? This is a very efficient way to solve these quadratic inequalities, all right? And especially when you get to more complex these more complex equations, the sign chart is a very good method to use, right? So are there any questions? Are there any questions on how we solve this? Or any concerns, questions, anything? So I'm assuming there are no questions. Or are you still taking notes? Does anybody still need to take notes on this method? Does anybody still need to take notes? All right. So actually, let's modify this a bit. And this, please answer in the chat. What if this was less than 0? Okay, then this wouldn't do anything. What if this was less than 0? If this were less than 0, then what would our solution be? What would be the answer if this were less than 0? Are there any answers? If this were less than 0, x minus 2 times the quantity of x minus 5 less than 0, then our interval would be 2 to 5. 2 to 5. All right, because multiply a positive with a negative, then that would make negative, right? That's what we want. So our interval would be 2 to 5. So that's our solution. All right, our solution is this. Okay, are there any questions over this? Any questions? All right, we got some answers. Very good, very good. Okay, so now how about you guys do some practice with this? All right, so let's do some practice problems. Okay, so let's start with this. This is quite an easy one. This is very similar. It's almost identical to the one that I just gave you. So please do your sign chart, all right? Make your sign chart, and that's how you're going to solve. Okay, so I'll give you a few moments to solve this. All right. If you have any questions after this, please ask them. All right, we have one answer, I hope. Okay, so let's see Steven's answer. Great job, Steven. Great job. All right, you got the correct answer. Very good. Did you use that sign chart method that I taught you? Did you use it? I hope you used it. It's very efficient. Yep. Yes. Very good. Very good. All right. So as you see here, the sign chart is very efficient when we're doing things like this. So how do we start? All right. Let's list out the zeros. All right. What makes a zero? What makes a zero? 2/3 is 1. All right. And then what else makes a 0? All right. 4/7. Okay, 4/7. Actually, wouldn't. Yeah, 4/7. I think. No. Hold on. I made errors. 7/4. 7/4. I thought it was 7x instead of 4x. Alright, 7/4. Okay. So after you've listed out the zeros, then there are intervals. We have 3 intervals in this problem. So let's list them in the sign chart. Let's make our sign chart. All right. And then let's do it. So negative infinity to 2/3, and then 2/3 to 7/4, and 7/4 to infinity. All right. I hate this. This line needs to be better. All right, infinity. Okay, so after you do that, you list the factors. 2 minus 3x and 4x minus 7. And actually solve them. 2 minus 3x is greater than 0. When is it greater than 0? Negative 3x is greater than negative 2. X is less than 2/3. All right. So x has to be less than 2/3 to be positive here. All right. So the only positive thing, the interval, only positive interval you get here is negative infinity to 2/3. All right. So what about 4x? Minus 7, when is that positive? So let's solve that as well. 4x minus 7 is positive. All right, x is greater than 7/4. All right, so let's see. Negative, negative, positive. Okay, and then you check your results. What are your results? All right, multiply these two together, you get negative. Okay, multiply these two together, positive and negative. So the only thing you get here is 2/3 and 7/4. Now, this is the correct answer. Actually, it's not a correct answer yet because it's greater than or equal to 0. So it can be equal to 0. These zeros, they don't have to be excluded. So it can be greater than or equal to. So they can be included. And when you're including these values, then you use a square bracket. All right, it's a square bracket. So are there any questions on how to do this problem? Are there any questions? If there are any questions, please say them. Right. And please make sure to take notes on these. Okay, so I'm gonna give you a bit more practice with these. Okay, a bit more practice. Actually, yeah. Okay. So let's do another easy one, and then we're going to move on to these, which are pretty hard. Yeah, they have more factors. Okay, so yeah, let's do this first. Maybe we will do the other ones next class. All right, so 2x squared plus 3x minus 5 is greater than or equal to 0. I'll give you a few moments to do this, and I'll check back in a few minutes. All right. And please put your answer in the chat box. Okay, and if you do have any questions, please ask them. I'm surprised that no one has any questions. This is a pretty hard subject. Don't be afraid to ask questions, and please do take notes on this. It's very important, and using this sign chart will be more efficient when you're doing things. All right. So are there any questions, any answers yet? Answers. All right. So x is less than or equal to -5/2, and x is greater than or equal to 1. Great job, Stephen. Great. And Edward, you got the numbers correct, but you didn't actually get the answer correct. You need to use a union sign for this, all right? A union sign. Okay? Because this is, yeah, like a union sign. Okay, so let's do it. So what are our zeros? Actually, we don't even know the zeros yet. Let's factor first. So using our x method, let's factor. So the factors of -5 and 2 must equal 3. So let's see, does this equal 3? Yes, it does equal 3. So after we factor, x minus 1, 2x minus plus 5. All right, and that is greater than or equal to 0. So let's do it now. Let's list out our zeros. What are our zeros? Okay, our zeros. There's 1. Okay, there's actually, what comes before that? There's actually -5/2 first, right? And then we also have 1. Okay, and we have 3 intervals once again. Okay, so now let's make our sign chart. So all right, so we get -infinity to -5/2, -5/2 to 1, and a 1 to infinity. All right, so our factors, x minus 1 and 2x plus 5. So when is x minus 1 positive, right? There's a negative, negative, and positive, right? Whenever x is greater than 1. So when is 2x plus 5 positive? It's whenever x is greater than -5/2. So you see here we get positive, negative, and positive. So the answer would be -infinity. And careful here, it's greater than or equal to 0. So square brackets, people, square brackets. Okay. Union, you have another one here. All right, so it's -infinity to -5/2, union 1 to infinity. Are there any questions? Any questions? Any questions to, okay. So if there are no questions, then I will end this class because these two problems are a bit too hard for us to do now. So I'll teach them to you next class. And so thank you everyone to coming to this class. Right, thank you for listening and have a great day. And of course I chose an optical illusion for the background. The sparrow kind of seems like it's moving. Kind of. Alright, so thank you everybody for listening, and I'll see you next time. Right. Yay, no problems. You're having problems. Of course you need more problems, Steven. Alright, you don't have enough problems. Alright, let's go. Okay, actually I'm gonna go. Bye.